In this video, we are explaining the wave scattering of light. Scattering occurs when light bounces off an object in variety of directions. The amount of scattering that takes place depends on the wavelength of light and the size of object. There are different types of scattering. They are Rayleigh scattering, Meese scattering, and geometric scattering. We use the MEP software that is available in our lab to observe different scattering phenomena. MEP is a free finite difference time domain simulation software package developed at MIT to model electromagnetic systems. MEP uses dimensionless units where all these constants are unity. Terms like transmission spectra frequency is expressed as a ratio anyway, so the units end up cancelling.
Our objective is to observe different scattering patterns of light by varying the obstacle size. The parameters used in the computational method are
the computational cell.
We are going to put a source at one end of the lattice and watch it propagate down the lattice in the x direction.
The obstacle.
The obstacle is specified by a metal block of size 0.1 by 4 by infinity centered at 0, 0.
The source frequency.
A source of frequency 0.15 is used.
The absorbing boundaries.
Absorbing boundaries around our cell of thickness 1 around all sides of the cell. As we said earlier, there are three types of scattering. Meese scattering occurs when obstacle size is comparable to the wavelength of light. This simulation clearly shows the scattering phenomena.
Meese scattering explains the color of clouds. Meese scattering occurs when the diameter of the atmospheric particles are similar to the wavelength of the scattered light. Mie theory has been used to design metamaterials. Mie theory has been used to determine if scattered light is from the tissue corresponds to a healthy cell or a cancerous nucleus. Rayleigh scattering occurs when the wavelength of light is far greater than the obstacle size. The simulation clearly shows this type of scattering. We do not observe much of the scattering when there is single obstacle, but when there are more number of small particles, we clearly see a difference. Rayleigh scattering explains the blue color of sky, and also the reddening of sunlight is intensified when the sun is near origin. This is also due to Rayleigh scattering. Geometric scattering occurs when the obstacle size is far greater than the wavelength of light. Here we can clearly see the geometric scattering phenomena. In day-to-day life, we see geometric scattering in many cases, such as reflections from day-to-day objects.